Let's talk about reflexes. Now, reflexes are the most basic of motor patterns. They are involuntary, relatively short latency, and stereotyped responses that are set into motion by an environmental stimulus. The components include the receptor for the transduction of the signal, as we've discussed before. Also, the components include the primary afferent fiber, which conducts to the CNS, the reflex center within the central nervous system, which are neurons within the central nervous system, typically a interneuron and a motor neuron, effector fibers, that is, motor neuronal axon from the CNS to the periphery, and then the effector, which is most commonly skeletal muscle, or in some cases of the autonomic reflexes, you'd have smooth muscle, which produces the response of the reflex. The primary afferent fiber can end in that spinal segment or can ascend or descend multiple segments to generally end on interneurons or in some cases motor neurons directly. Interneurons are connecting neurons, which may have short axons to connect to immediately adjacent neurons or can ascend or descend over multiple segments with a much longer axon. Interneurons can connect neurons within a neuronal pool to activate more of a given muscle, or can connect between different motor neuronal pools to get simultaneous action of both synergists, and interneurons can inhibit antagonists and can produce interaction between both sides of the spinal cord. Alpha motor neurons to skeletal muscle, and we think of these as the output as the effector of the reflex, but it can also have collateral connections to interneurons to control output, specifically as shown here, Renshaw interneurons, which can produce inhibitory shaping of the motor output. Now, the first type of reflex we're going to talk about is the myotatic or stretch reflex. It has excitation which can be monosynaptic with only one afferent and a motor neuron, but it also can be polysynaptic with excitation and inhibition. Clinically elicited by tapping the tendon of the muscle with a reflex hammer, which produces a small stretch of the muscle, which produces a reflex, a very brief, brisk contraction of the stretched muscle. Commonly tested are the patellar tendon reflex, which is the femoral nerve via L4, the Achilles tendon reflex via the tibial nerve via S1, the biceps reflex, which involves the musculocutaneous nerve via C6. Also commonly tested are the brachioradialis via cranial nerve C5, C6. Via the radial nerve via C5, C6. Triceps, which is radial nerve also via C7, and the masseter, which is using cranial nerve 5. Now, the stretch reflex is mediated by activity of the muscle spindle. As we saw before, stretch of the muscle produces activation of the primary and secondary afferents of the muscle spindle, which activate the spinal motor neurons via group 1A or 2 afferents, respectively. The pattern of activation within the spinal cord is excitation, that is, autogenic excitation, of motor neurons to the stretched muscle, which can be monosynaptic. The reflex is at least disynaptic inhibition of the motor neurons to antagonistic muscles. This is called reciprocal inhibition. Because of this, excitatory primary afferent must end on an excite an inhibitory neuron before it in turn can inhibit the antagonistic motor neurons. In most cases, this excitation of agonist and inhibition of antagonist is multisegmental because agonists and antagonists are generally innervated by different segmental levels. There are exceptions, such as the anterior and posterior deltoid. The tendon tap, elicitation of the stretch reflex, is a good example of a tool to test CNS excitability. However, the stretch reflex is not just there to test central nervous system excitability. The tonic stretch reflexes function to constantly be active to control muscle length, with a stretched muscle producing a reflexive contraction. Maintain posture by regulating postural sway. Too much sway overstretches the muscles that reflexly contract to bring you back into alignment, and even providing the circuitry to allow descending activation of one muscle and the inhibition of its antagonist. Now, excitability of the stretch reflex is regulated by gamma efferents, contraction of the ends of the interfusal fibers of the muscle spindle to increase the firing of 1A and 1B afferents, which increases the gain of the stretch reflex. You can produce this by a procedure known as the Jędrusik maneuver, which involves pulling clasp hands apart as hard as you can to increase the tendon tap of the lower extremities. Then there is the GTO reflex, or also referred to as the inverse myotatic reflex, mediated by Golgi tendon organs, located in the tendons and responding to muscle tension. This reflex involves autogenic inhibition and results in excitation of agonist and relaxation of the agonist and contraction of the antagonistic muscle. As we've discussed before, the GTO reflex was originally thought to be just protective, but it is more associated with regulating lower motor neuronal excitability, and therefore the regulation of muscle tone, and to a certain extent the control of fine motor function by regulating the excitability of lower motor neurons. The nociceptive reflex is a reflexive motor response to a suddenly applied noxious stimulus. It produces withdrawal of the limb from the offending stimulus with a contralateral postural response involving excitatory discharge, which spreads throughout many segments by way of spinal system. The nociceptive reflex is characterized by flexion of the injured limb, that is ipsilateral withdrawal response, and is accompanied by extension or anti-gravity response of the contralateral limb in the lower extremity. This is mediated by excitatory interneurons that cross the spinal cord level. This is a multi-segmental reflex because it involves contraction of not one flexor muscle but all the flexor muscles of that limb, and not one extensor muscle but all the extensor muscles of the contralateral limb. There, of course, is reciprocal inhibition of antagonists of the ipsilateral and contralateral limbs. But in the upper extremity, the contralateral anti-gravity response is flexion. This is seen when you hurt one hand. You do not reflexly extend the other arm, but rather flex it. So you see that flexion of both the ipsilateral damaged arm and contralateral arm. Now, we have been talking about somatomotor reflexes with somatosensory input and skeletal muscle output. But there are also visceral motor reflexes with autonomic afferents from internal organs and autonomic efferent activity back to the viscera. Illustrated here is an example of irritation of the bladder, such as stretch of the bladder with urine, produces reflexive bladder detrusor muscle contraction. There are also somatovisceral reflexes with somatosensory input, but with an autonomic motor output to the viscera. Illustrated here is the cold temperature which produces reflex piloerection. Finally, there is visceral somatic reflexes with a visceral autonomic reflex or afferent, but the skeletal muscle motor output, commonly responding to visceral pain such as contraction of the abdominal muscles with inflammation of the appendix.